So I'm Megan Risdal. I'm a community advocate, and I manage our datasets platform at Kaggle. And this is Wendy.
And I'm Wendy. I'm a data scientist at the competition platform.
Cool. Yeah, and we're going to be talking about Kaggle Kernels. So you may have heard the word kernel before, but you may not be familiar with what it means on Kaggle. So we'll be going deep into that and sharing with you what we've learned from our community and how they use notebooks on Kaggle. So those are our Twitter handles if you want to follow or add us. All right, so just to give you an outline of what we'll be talking over, give a little bit of background on Kaggle for anybody who's not familiar with Kaggle or doesn't know about all of the different components of our platform. Then the focus of our talk is kernels, so telling you what are kernels and what are their features and how our community uses them. In the third section on community stats. So we have a lot of notebooks, we have a lot of content that our community has created, so we have a lot of interesting things to share. And then finally we'll look at how our community, like some actual examples of collaborative data science using kernels on Kaggle. So first, the intro to Kaggle. I still do have to ask, if everybody who's heard of Kaggle, could you raise your hands? OK, cool, that's encouraging, but don't feel bad if you haven't heard of us, that's all right. And then who has competed in a competition or made a submission to a competition? OK, cool. And then who's actually heard of kernels before and is familiar with kernels? OK, still a really good number of people, cool. And then finally, who's seen our datasets platform or downloaded a dataset from it? Awesome, very cool. All right, so sorry for the buzzword, but Kaggle is known as the home of data science. So really, we see it as a place where people can come to learn data science, compete in competitive machine learning competitions, and we give them really interesting problems to work on. But it's also a place to have fun and just interact with other data scientists from all over the world, from really beginner to experts that are topping the leaderboards. So you probably first heard of us as a competitive machine learning platform where hosts come to share their supervised machine learning problems with our community. We publish datasets, or they share their data with our community, pose a problem. They would typically, historically, download the data, create a submission file, submit it, and get a placement on the leaderboard. And then the winners end up getting cash prizes. We also host recruiting competitions. So that's really been Kaggle's bread and butter for the past 7.5 years. And it's actually because of competitions that we've built up the world's largest community of data scientists. By data scientist, I really mean anybody who works with data usually a lot of machine learning, of course, but it's really anybody who works with data. So we have a global user base of over 1.1 million people, registered users. They come from all over the world. We have a lot of users in the United States, of course, but we also have many users in India, China, Russia. So it's a really, truly diverse community coming together to work on interesting problems. And it's this community that has allowed us to, or enabled us to really enable our community to do more with data than just get their name on a leaderboard, compete. So it's becoming much more collaborative. First, with our datasets platform that we launched a year ago, anybody can you can find datasets. We have a catalog over 2,000 datasets, and discuss those datasets in our community, analyze them and discuss them. And then kernels, which is the focus of the talk today, which we launched about 2 years ago, enables people to write Python or R flat file scripts, scripts. Or hosted Python, Jupyter Notebooks, which everybody's familiar with Jupyter Notebooks. So that's really the focus for the talk today. So kernels. So what are Kaggle kernels? We really see, this is where the name comes from, we really see a Kaggle kernel as all of the ingredients required to grow your work as a data scientist, to make it something bigger than just working on your laptop alone. So it combines these 4 things: environment, datasets, community, and infrastructure. And I'm going to try to use like an analogy here of the seed. A seed, comes with an environment. It's got prepackaged nutrients that allow a seed to become an oak tree. And kind of the same way with Kaggle kernels, we provide an environment, which is a Docker. It's all in a Docker container. We have preloaded libraries that a data scientist would typically use. Our Docker file is open on GitHub, so anybody can submit pull requests. So it's really kind of crowdsourced to be something that enables people to share the same reproducible environment. And then datasets we see as kind of like the soil. It's sort of like the external nutrients that feed the seed, feed the kernel. So when you create a kernel on Kaggle, you have access to this catalog of what I mentioned, over 2,000 public datasets, as well as the datasets associated with competitions. There's no download required. It's all in the cloud. And then finally, or next is community. And I won't try to stretch the analogy further here, because I think community is actually really quite unique. So when you're sharing, or when you're creating a kernel on Kaggle, you're doing so in this huge community. So you share your code, you get feedback on your code, you can iterate on it. All of the code is public, so if you're a new user who's never used a certain package before, you can go find examples for it. I like to call it code spo. It's code inspiration, it's right there. And also, any kernel that you create, anybody else can take it and fork it. So that means that they can just make a copy of it and then extend that work. And that also is its own sort of like collaborative community there. And then finally is infrastructure. So all of this is code that we execute. So we're extending these compute resources to our global community, enabling them to do things that they wouldn't be able to do with just their laptop locally, especially a lot of users from other parts of the world. And Wendy's going to talk a little bit about more details of our infrastructure in a little bit. So yeah, that's Kaggle kernels. It's that, conceptually, it's like all of these things all wrapped up together, which is why we picked a somewhat confusing name for it, but it's meaningful. To add a little more, something a little more concrete, this is what the kernels page looks like on Kaggle. I think we're over like 160,000 public kernels. And every piece of data on Kaggle has a list of kernels attached to it. This is the global listing, so it's all kernels made public on Kaggle. And then creating a kernel is really as easy as clicking a new kernel button. It spins up this environment, and you can select either a script or a notebook. So a lot of users use scripts because it's just one file that executes end to start, and it's ideal for fitting models and making competition submissions. And then notebooks, as we know, are really ideal for more exploratory data analysis, where you want to interleave narrative with Markdown and code, and share data visualizations, maybe share a story. If I was walking through here, I would click Notebook, and this is what I would see next. This is our notebook editor built on top of Jupyter. And you get the option to add any data sources. You can add more than one. You can mix and match, and it automatically is part of your environment. So you can search data sets from our public data platform and competitions. So this is the notebook editor after I've added a Bitcoin historical prices data set that one of our users published that's really popular. A few things to point out here is, you can see my cursor. So there's input files. If I click to expand that, I can see a file preview of the data set that I'm working with. So readily able to see the different columns and their descriptions. And I can also add additional data sources if I decide to later on in my analysis. We enable users to write their code in either Python or R. I am also an R user. Python here, all of your code is private by default. So this is actually a pretty new feature for us in the last few months. And we've noticed that since enabling private kernels, people iterate a lot more on their code because you can perfect something, polish something before releasing it public for feedback from the community. And then, yeah, it's a simple, sharing your code is you just hit publish. And so it's really that easy. So Wendy's going to talk a little bit more about the details of the Kaggle Kernels infrastructure.
Thanks, Meg. So Kaggle Kernels infrastructure is conceptually, it's very simple. Of course, there's a lot of details. This is a very high-level overview of the Kaggle Kernels infrastructure. We provide free compute for our users, so of course we don't want people to abuse it. So we have some compute limits. So it's 1 hour from, actually this is unofficial, it's like we quietly increased it maybe in the last few days. Every kernel has 1 hour of runtime limit, 16 gigs of memory, 4 GPU cores, and 1 gigs of output storage. Your data is not included in this output storage, so data could be very big, the input data that's living on Kaggle. So we basically, the top box basically is the browser. So we wanted people to you only have to have a browser. You open the browser and you can start coding, and all the data lives on the cloud, your code lives on the cloud, and you push it and it just runs on the cloud. So to make that possible, everything is interacted through the Kaggle web tier, which is the blue box in the middle. And the data is all of the data, not just the execution data, but also all the metadata of your kernel is saved in the SQL server as a relational database. And then your code or the data files and all these larger files that need to be executed with the code are stored in blob storage. So that's like a file storage. The other thing is more for messaging and control of the worker that's in the back end. So that's done with a PubSub. We use Redis now, but we're moving towards something else on the other side. So the bottom box is the kind of like the heart of the execution of the kernels. So the kernels, as Meg stated, there are two types, two main types. One is more like the flat file. So either like it's kind of like the text file of Python or R, Julia code. So that's executed from, these are all encapsulated in Docker containers. So those are community managed. So the Docker files are all on GitHub that you can commit and put a pull requests for packages that you want to use. But most of the stuff usually I see most of the stuff that I need are already in there. For the Jupyter Notebooks, it's a little different. So so it's not just like grabbing a text file and then execute against it. So for kernels, you have a session, and then we let people interact between the browser and the session through this cloud. So that's basically our very high-level overview of the infrastructure. So about some community stats we wanted to share. It's very interesting because 2 years ago, about April 2015, we started to launch Kaggle Kernels. And at the time, we didn't have all these data sets and kernels. It's really a competition site. And we launched this, and we feel it'd be great. Everybody would love it. And we actually received a pretty big backlash from our community because nobody likes to work really hard on a competition where in the end somebody published a really high-performing script and then everybody's like jumping on that, and then you lose the competition. So the community actually gave us a really hard time. We fought for that. It's kind of funny looking back 2 years after, and we realized that a lot of people have changed their mind towards this because they realize, okay, we still all hate the high-performing scripts published at the end of the towards the end of the competition, 2 days before. But all of them agree that it's like, I changed my mind. I really learned so much from looking at other people's kernels and looking at other people's scripts, and just being able to search on methods that I wanted to use on regression or how to deal with this categorical variable is very valuable. And this is the usage graph. We now have over 150,000 public kernels and 62,000 authors. And you can see that it was flatter before and it really took off. There are a few very significant events that are in our history. We initially only started with the scripts, the flat file. And then we ourselves are Jupyter Notebook users. We realized that our community would love to use that. So we launched Jupyter Notebook on Kaggle kernels like maybe 6 months after that. Usage was still low, but we definitely saw the kernels starting, the Jupyter Notebooks started to take off. One very important thing that happened there was about a year after we launched it, we launched Kaggle datasets, and that really caused a kind of like an explosive growth of the number of kernels because people are realizing like you could just go and explore a public dataset on Kaggle and then start to work on it. You don't have to download anything, and then your results are already published, and then people can jump on and comment. So it's really fun. So that caused a big usage. A year and a half after our original launch, we felt that the Kaggle kernels was mature enough that we ran a competition that was very different from all the other competitions from before. This is a kernels-only competition. So instead of submitting your predictions as CSV files to Kaggle and then get a score, you submit your code through Kaggle kernels, and then you make sure that it's executable and it'll work, and then we can run it. To get new predictions if we have new data coming in. It was very, very, very beneficial for time series data to ensure that you have new data coming in and people are not overfitting. That design was very, for me, it was very revolutionary because we weren't able to design a competition like that before without the help of Kaggle kernels. We definitely experienced different events in time, and overall we're steadily or sometimes exponentially growing. We had a little debate, R versus Python. Every time it goes into a very strong debate. I try to be language agnostic, but leaning more towards Python. You see, we have this, Meg made this beautiful graph over time of Kaggle kernels language. R versus Python. We have a little other being Julia, but they kind of have disappeared. Python is definitely getting more and more usage, and I don't have a great explanation for this. My guess is maybe deep learning is taking a lot of attention, and people are trying new things on deep learning, and most of the code that I see in deep learning are in Python, but I don't know. You can make your own interpretation. The other thing we wanted to look at is, so we have, it's very interesting, right? Because like I use Jupyter Notebook all the time. I want to know what other people are using. Are people using flat files, executing Python, and what do they use it for? So we happen to have these, hundreds of thousands of kernels that we can analyze. So this is a graph of over time the popularity of the number of notebooks versus scripts. So you see that it was very flat before. The scripts, which are the flat files, were about similar, or the notebooks actually have less usage. But after a certain time, Jupyter Notebook just took off, and it doesn't seem like it'll change. The blue line is R Markdown, which is basically just R flat file. But it's interesting to look at. So we also have this notion of voting. So you can look at somebody's work. You can see the code. You can vote if you like it. You can't downvote. You can upvote. So we realized that a lot of times I really like the R Markdown kernels. And we realized that it's a lower volume on Kaggle, but they're generally very high quality. So they're very well voted. So we also could look at what are people using on Kaggle. So we looked at the top 1,000 most voted Jupyter Notebooks in each of the R versus Python languages, and then did a word cloud, and saw that it was not too surprising that scikit-learn was right there, pandas was right there, matplotlib, because we're looking at the notebooks. I'm sure for the flat files, not a lot of people would use matplotlib. Seaborn is also there. It's Kaggle, so there's a lot of machine learning stuff going on with scikit-learn, with keras, with metrics, and different kinds of models. I'm a little bit surprised that XGBoost was not on it, but I feel like maybe we're looking at the notebooks, maybe they're more in the files. On the other hand, for R packages, not very surprising that ggplot2 and the whole tidyverse is big up there. I actually had to reduce the font size for this graph, because if I don't, then ggplot2 is like half of the graph. Of course, caret is there. People are doing a lot of classification and regression on Kaggle. Yep. So other than analyzing code, we also wanted to look at how people interact with each other, because we have all these people interacting with other people's code. So we wanted to see what people like and what can you do to get more likes. We have this follower graph. So we launched this feature maybe a few months ago, and then started to get a lot of attention. So you could, if you like an author, you can follow them. Initially, the graph looked like this, and it started to progress, and then we getting more and more following. Basically, a user can interact with somebody else's kernel in various ways and various degrees of involvement, I guess. You could view it. You could see it. So on the right, I have a screenshot from one of the pretty good kernels from one of the competitions called Wikipedia Traffic Forecast. And you can view it. You could vote it. So that number 137 is the number of votes on there. It's earning a medal because it's gotten a pretty good amount of votes. You could, if you like it, you could follow the author. You could comment. So I copied one of the comments on the left side. So somebody made a comment of like, oh, great work, but didn't you see this? There's this issue. And the author very quickly replied, thank you for correcting me. I fixed it. So you could comment on those. You could also fork. So fork script on the right side is where you could make a copy of this kernel, and then you can just build on top of it. So you don't have to copy and paste everything. It's funny because the previous talk, Hillary was talking about version control and all these fork thing. When we first introduced Kaggle kernels to the community of all these data scientists, even some of the very high-profile Kagglers, very talented data scientists, they don't do version control. They're not familiar with fork at all. They were confused, while that concept was very popular in GitHub for software engineers. So these are very interesting ways that people could interact with Kaggle kernels. We also looked at interesting things like how many votes are you going to get, like the number of upvotes versus the user account age. And to our surprise, we thought, maybe if you're on Kaggle for a long time, you'll write better content that gets a lot of votes. And to our surprise, a lot of the very new accounts create very well-liked content, very well-liked kernels. And we're actually really happy to see that, because that's the whole point. We want people to open the browser, and there's no learning curve at all. You just start coding, and you don't have to learn all these 5 different tools to start using and sharing your stuff, look up GitHub commands all the time. You just click run, and then it's there. So we like that. It also helps, I guess, if you have the number. So we also saw that if you, because we have version control, so every time you hit run, we save a new version, so you can always go back. So we also saw that people are better at publishing something first and then go back and then iterate, or publishing something, get some feedback, and then go in a different direction or something. So we definitely see that the number of versions is related to the number of votes. The other thing is we don't know what's the cause of what, but if you have a lot of votes, if you have a lot of followers, then you have a lot of votes. So it could be that because you have a lot of followers, you have a lot of votes, or because you have a lot of votes, you have a lot of followers. So those are our interesting findings from exploring on all of our kernels. Our marketing team is doing this Kaggle machine learning and data science survey. which we're very excited about. We want to do like a Stack Overflow style, understanding our community, what tools people use, and stuff like that. So please, if you're interested in joining these research, and please help us out by filling out those surveys. We'll also, after we're done with that, we'll also publish these results, of course, on Kaggle datasets, so people can analyze them. I'm going to give back to Meg.
Cool, thanks. Yeah, so if you want to learn more about our community and how data scientists or people who work with data work, you can check out the results of that survey when we publish it on Kaggle datasets. So to kind of wrap up, I wanted to kind of highlight some actual examples of our users doing collaborative data science with kernels on Kaggle. It's just kind of a case study. So the first example is this playground competition that we launched a month ago or so. Playground competitions on Kaggle aren't for cash prizes normally. They use public data typically, so you can cheat, but it's just for fun. It's a way to learn and just interact with a new group of data scientists and other competitors on the platform. So this competition was a little bit different because we incentivized sharing code and data with cash prizes. And the challenge was to predict New York City taxi trip durations. But really, the core of this competition is not really a competition. It's about sharing code and learning from each other. So we had a bunch of prizes for 13 popular, helpful kernels. So we were awarding biweekly prizes. It's actually still ongoing if you want to participate. And then also we're awarding prizes, it looks like, I guess, in 22 days for like tutorial kernels, interactive data visualization kernels, and things like that. And then also $12,000 in prizes for top 3 supplementary data sources shared. So kind of what happened when we kicked this off, it's still ongoing, as I said. This is one of the very first, or I think this is the first or second kernel that we awarded a prize to in this competition by a competitions grandmaster, Beluga. And his kernel is a start to finish from EDA exploratory data analysis of the data set through some data processing and then some feature engineering. So you can see he's defining some different clusters of Manhattan here. And then he also shows you how to fit a model using XGBoost, incredibly popular in our community, and make a submission to the competition. So if you're a new user, like you're going to look at the kernels page of this competition and see that somebody has already put together this beautiful analysis, helped you understand the data, helped you understand how to create a submission, and this is something that you can build off of and work on by forking it and potentially create something even better. And because he's a competitions grandmaster, he's very competitive and he'll try to beat you again. So really, it's really actually kind of beautiful to see this kind of stuff openly shared in our community. And it's quickly become the most popular competition in terms of kernels so far. So there's a lot of code, you should check it out. And then kind of the second example of incentivizing collaborative data science in our community is we kicked off this awards series. Every week we're awarding $500 to basically a just excellent kernel created on our datasets platform. So if you share a really helpful tutorial that helps others get started with some new tool or library or even a unique data set, you could win $500 on our weekly award. We'll probably be announcing this week's award tomorrow. And then also we're doing $10,000 for datasets awards. That's if you share a dataset on Kaggle in August, you'll be automatically considered for some of this money. So this is, I think the person who won the kernel award last week did this gorgeous exploratory data analysis on this dataset of 10 years of political conflict in Africa. This is a data set that was published by one of our users who probably cares a lot about this issue. And it was actually a completely brand new user who decided to explore this data really extensively. And this is an R Markdown kernel. It has really nice code folding, so you can see the code underlying the analysis. It shares some beautiful ggplot, but then also does some exploratory data analysis using an interactive mapping library leaflet, which I've never used before, so I was able to kind of check out the code, and I could fork this maybe and play around with it. So those are just some really cool examples, and we have this catalog of almost 160,000 kernels, so it's only growing. So to wrap up, what have we learned from putting together this talk, really taking a look at what our users are creating? We've definitely learned that Kaggle Kernels has been a great place for our users to showcase their work, learn new things, and collaborate. We make it easy for people to get started. We make it easy for people to find examples and find inspiration and find people who are experts that they can communicate with all in one place. And then, with our large community of 1 million data scientists, registered users, we can learn valuable industry trends, both by looking at what libraries people are using, what languages, and things like that, and then also with the machine learning and data science survey that we'll be publishing. And then finally, probably most importantly, is if you give people good data, if you enable people to share data and ideas and interesting problems, and also we're very glad and happy to be extending the compute resources that we can to our community. We see a lot of great content, and our mission is to help the world learn from data. So it's amazing to see that in action with kernels. So if you have questions, if you want to publish a data set, you can reach out to us here. Yeah, questions?
So it's a great playground that you have in the Kaggle space. Do you make it easy or want to encourage people to just sort of push the download button where they get the whole thing, resources downloaded to their personal computers, or do you try to discourage that?
I think we want to enable people to do both. So I think it's more rare to have the ability to do that in the cloud and have those resources free to you. Users are still absolutely free to download the data sets. And we make our Docker file. People can pull our Docker file as well. And they could recreate Kaggle locally if they so wish. So, yeah.
We have heard really good feedback from our users that sometimes the data is just really big, so it's nice being able to just play with it on the cloud instead of having to spend days downloading it.
Any other questions?
What are the plans in terms of long-term availability of those kernels?
Availability.
Yeah, long-term.
You mean, like, are they going to live on Kaggle forever, or more like, can you execute them?
Yeah, both. And do you make it simple to cite them? Have you thought about this in general?
Yeah, so we don't have any plans to make them unavailable at any point. All public kernels are released under Apache 2.0 license.
Yeah, we don't have any reason or plans to not make them not available, or like take them and then use them and sell them or something.
More about maintenance, like my binder kind of thing, so that there was still the dependencies are clear and it was still working.
Yeah, that's a good point about dependency and stuff. That could be a problem. We don't have any plans to backward support old packages or deprecated methods and stuff like that. We think we're a platform that the code user probably should be responsible for that, or like somebody should fork the code and then make it more applicable, or like try to edit it.
Any other questions?
Yeah.
When do you plan on publishing the lessons learned, the graphs and things you showed here? Is there a timeline for that?
I can share it anytime.
we can share them on Google Doc very soon.
Yeah.
Yeah, but I'm glad you like it.
Oh yeah, every time people take pictures of all the slides.
Awesome. That's a good point.
Not sharing it as the kernel.
Well,
yeah.
we actually do have a meta Kaggle data set. It's very out of date right now. It's like literally on my to-do list next week to update or in the next couple of weeks. I won't make it too hard of a promise, but to update, some data that we can share about these things. So that you can actually analyze it, and we'll be able to reproduce some of these things as well.
Yeah. We're actually really excited to eventually we'll probably have like database as a data source for Kaggle. Right now it's all from like CSV files and data files like that. So therefore, we can't use Kaggle kernels for doing this analysis because a lot of that is not on Kaggle. We have to like port the data over to our local computers and do analysis that way. And then we can't share between us. So we're like, duh, this is why Kaggle kernels exist. And we can't use it yet, but hopefully that'll be soon and we can connect it to our database.
Well, let's thank our speakers.